Hey everybody, this is Larry. This is me catching up to not doing this previous week, which is the weekly contest 460. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I think this is the only one I'm missing. Hopefully it is. But yeah, I'm just trying to, get my problems in, have some fun. And yeah, that's it. Let's go. Hit the like button, hit the subscribe button, join me on Discord, and hit me up on my apps. Anyway, all right. Am I ready? I have my notebook, pencil. Let's go. Go. Do. I always have to reset the layout. Yeah, there's a lot of like clicking in the beginning. Okay, there's a medium Q1, so let's go. Maximum possible sum. How would it? So you take the min and then max 2 maybe? Min max 2, min max 2. No way to do about it. I mean, I feel like that's a previous problem, but in any case. Yeah, so then, yeah, just put in a Q. Q dot pop left, Q dot pop, and it's going to maybe something like this. Let's try it out. Usually tell you what's the thing. 5 and 20, YOLO submit. Okay, good. Max number of subsequents after 1 and 2. Man, these titles are getting ridiculous, but okay. You're allowed to one applicant. Okay. Return the maximum number of LCT subsequents that can form after one insertion. I mean, clearly you want to remove either add an L or a C or a T. So the L you would always put in the beginning. T you always put in the end. C maybe you have to brute force. Like you try all of them. Can you try all of them in the fast way? Actually, I'm confused why this is hard, but because the C, you just prefix summit, right? So okay, yeah, I think this is probably right. But all right, so then, yeah, okay. Score, everything score. Let's just say we have. Let's go best. So how do I say it? So for every L, no, I mean you just do it the same way, right? Yeah, I'm just being slow. Okay. So yeah, okay. Yeah, I'm just being dumb. I think this is a dumb problem. Maybe that's why. Okay, so let's just, because I'm trying to solve two things at the same time, and it shouldn't. Okay. T is naming things is hard. C L00, right? Actually, so then we want to say, yeah, if S sub I is C, then we want to say score we added by the number of things on the left plus times number of t's, and that's it. Else if this is where having a case statement would be nice, but anyway. There we go. L plus S. Right. Plus T. This is force, and then S. True. Right, and true is if we add it here. Right. Oh, true is if we find a maximal place to add it. Right, so then maybe we have a best here. So something like that. 240. Am I not super confident about this, and we probably could do some F maxing. But I think I'm ready to YOLO. I mean, I think if I get it wrong, then it's a misunderstanding of the problem. Oh no, this is bad. I mean, yeah, I kind of got lazy here, honestly, because it doesn't have. We don't always own. Yeah, we needed this in everywhere, not just here. I think that's the issue. So we inserted. The timing is tricky. I mean, okay. I mean, this is just really dumb, because we want to try it before and after. And if this is an L, we want to try to add it after. And if this is a T, we try to do it before, right? Why is that pace so weird? So that it's, which is fine. And then just in general, I think, yeah, that is just dumb. Maybe I should, YOLO submit, please. Okay, yeah, the dumb part is that honestly, I was like, as I was submitting, I'm like, maybe, I think I should have tested that case, literally, or close to it, but sometimes happen. That took 6 minutes. I didn't think I was that slow, but these days I am a slow old man. Okay, Q3, minimum jumps to reach N via prime teleportation. Nums N start at 0 and go to N minus 1, okay. Could go left or right, okay. Prime, if num sub I is prime, any index that J is an I, okay, because they're not prime. Okay, so it's just about constructing graphs. I don't know why they don't do this in a better way. This is kind of dumb. 10 to 6, like it's the same problem. They change it to 10 over or 10 to the 5th. But yeah, and I still write it out. Good. The prime sif. You get time. Right. Okay, but that's not quite. I mean, that's fine, but we probably have to do a little bit better. We might have to make modifications. I can't just template it in my head, or maybe I could just copy and paste it if I'm going to template it from my head without thinking. But 10 times each number does 10 steps or whatever. 6 what's 10 to the 6 again? 10 to the 6 is 20, right? 2 to the 20. And so like 10 steps each. Okay, fine. So if you're all on a prime, you could go anywhere else. Okay. Right? Not the other way around. Easy mistake. I forgot how to write this. Actually. I don't know. I mean, it's fine. Maybe this is fine too. Okay, that's all I need to change. I don't know how to change 0 and 1. But not primes, but maybe just primes. What do we have? Okay, maybe I have to just special case it. Alright, so you would... Oh, I was gonna say you would only jump to the right, but that's not true. So, okay, just buffer search it. Why? I think I was trying to be too clever on things. Just buffer search it, it's fine. Right. Something like this, right? And now we can either go -1 or +1. So okay, and then now we have to do the prime jump thing, right? Okay, we should probably pre-process the other way, right? Okay, fine, yeah. Nope, if it's not a prime, then yeah, then start at the number. The two things we have to do. Okay, so then, okay, that's fine. That's fine. So then now we have a, and we don't always want to go to the max, so we have to actually store it. Okay, fine. I just call the way that I think about these problems is this particular structure setup is that I think of it as a train. If that makes sense. I guess let's use a set, right? Well, it's not a prime number. We go right, and then now f of yep. Let's say I for index, right? Is that right? So we get the indexes, and this is an add because it's a set, and then now we want to say fd is equal to I don't know, just it's a set, right? Now we take a train, right? So then now, oh no, this is right. So then if prime sub now is the index of num sub now, if prime sub num sub now is not num sub now, then yeah, we go on the train. And num sub now, not in fd, and fd dot add num sub now. The reason we do it this way so that you don't check it every time for all the loops, because then now for x in f sub prime sub num sub now, this is a prime, right? No, this is wrong. Oops, that's y. So if it is a prime, and it is not, we haven't visited yet. FD is like F done, and F is the F train, is how I think about it. Okay, so for every stop, we just go, right? Yeah, that's the index. Yep, okay. Is it always possible? It is always possible, right? So yeah, what was it called? Best. 2 and 3. Hopefully, did I mess something up? Is it infinitely looping? No, this should only happen once. I mean, this may be slow if we don't do this correctly, but it should be correctly. Right. 1 plus 1. That's weird. What am I infinitely looping on? Oh, 1 is weird, isn't it? Because this is, well, no, this will always be wrong, so we don't ever jump on 1. And 1 is not a prime. What is going on? What am I appending? I update. Append. Huh? Alright. Oh, is it here? Actually, okay, so maybe that's where I was wrong. Okay, let's see, what am I doing wrong? So, while this is not a prime, we don't have by this biggest prime, right? Okay, let's see. Where did I mess up? Maybe I rushed it. Output limited, please. Oh, -1. Oh, because you go to 1 and then -1. Okay, this is awkward. It's 0 possible input. 0 is not possible. At least they caught it for me. So I mean, because it would be really sad if it'd be really sad if you know, we did it later. Okay, this is very wrong for some reason. But yeah, yeah, a lot of debugging today. I mean, the algo is fine, but the implementation maybe not so fine. 1, 2, we still go to 4 by going to +1, right? Why are you not visiting? dx now is the index. So why is this not working? 2 goes to, I mean, nothing else, this should work, right? Now plus dx, now plus dx. Oh, now plus dx. Yeah, okay, well, there you go. 3, 3, 4. I mean, it's wrong, but maybe I'm just off by 1 number of jumps. Why does this have? Was it? Why is best of 0? Best of 0 is, oh, I just set it to 1. I was like, why is this 1? Alright, 2, 2, 3. Okay, where's my print statement? Let's get rid of it. Where's my print? Oh, there it is. Alright, not a hard problem, but a dumb problem for me. I mean, and doubly so now. 757. Expected is 1. 7 to 7? I guess so, huh? I didn't think about that. I mean, I think I just didn't understand it correctly. I mean, I guess that is, like, you can jump from a prime to any other prime, or the same prime, right? So I guess that's the thing, and we explicitly do not do that. So yeah, okay, I guess I just didn't consider it. It's fine. The problem still stands. Yep. I added attempted, and just like whopping in your face. No silly mistake, please. Oh. Wait, why? 5. It goes to 3 and 5, right? Oh, because it doesn't do the last prime. I am a silly boy. I am a silly boy. Okay, and then now I guess we can actually take this out. Man, I am a silly boy. Silly boy. Unexpected. Okay. I mean, it's hard to be excited when you made 2 silly mistakes. But on a problem that you should be able to do. So really no bueno. Oh, but still top 226. Not bad, I guess, considering. I guess they remove a bunch of cheaters by now. Well, maybe except for the number 1. But all right, let's take a look at Q4. Partition array for maximum XOR and AND. Okay. I guess not many people got this one as why is what I was saying, but all right, let's take a look. So many wrong answers for me. All right, 3 possibly empty subsequence so that each element belongs to 1. Okay, XOR plus AND plus XOR. That's weird. Because there's subsequences, so this thing, the sandwich, if you will, the AND sandwich is kind of nice, but yeah, so you definitely want to AND. So the first thing to notice is that AND, you probably just want it to be 1 number. Maybe I want to say it almost doesn't make sense, but to maximize AND, you only want it to be 1 number, because otherwise you lose bits anyway. So I don't know if that makes it better or worse for XOR. And then you have 2 more AND things or XOR things. In this case, they say that this is better. For example, maybe I'm wrong on that because you have the 2. Well, use 4-way numbers, so you can use AND to 4-way numbers essentially. Does AND always have to be one of the numbers? No, I guess it could be 0, but that is just like really getting rid of numbers that you don't want to XOR. How do I want to think about this? Oh, 19. I guess that's the first thing I should have looked at, to be honest. Okay. I mean, 3 to the 19 is clearly too slow, right? I know I'm talking a little bit more than if I was actually doing a contest, but how much time do we have left anyway? An hour and 7 minutes. Probably could have had more time. But in any case, I mean, this is, virtual, so it's a little bit, I guess I don't take it as seriously as I used to. But in any case, okay. 19 is interesting. What can I do with 19? 3 to the 19 is still too big. So maybe with the can I do some kind of 2 to the 19? Can I do meet in the middle? Meet in the middle. What would meet in the middle look like? And what's the AND? How do I reduce? I guess the tricky part about this problem is reducing it from 3 to the 19 to the 2 to the 19 somehow, times some numbers. It's 10 to the 9, so effectively, well, there's still only 30 bits, so still a dirty number thing. XOR. So you have to make like 1 observation probably, or maybe 2, I don't know. Can I do divide in the middle? Does that even matter? What would divide in the middle look like? Or meet in the middle? You have 3 things. And then then maybe you do a try greedy thing. No, that feels weird. I mean, I don't know why. Yeah, I just kind of confused about this line because if multiple you can consider any of them, but we're not returning the answer. We're just returning the number, right? So I don't know if they originally intended to write this a different way, but that's interesting. And like just forgot to leave, like left it in there. But can I? Oh, can I do it one bit at a time? What would one bit at a time look like? Can you? You have to group them together though. Well, yes, but you're greedying, remember? Because if you do it on the most significant bit, is it easier if you do it on the most significant bit? Well, there's just ones and zeros. Right? What would the ones and zeros look like? So you want an odd number of ones in XOR A and XOR B, and then maybe one in A. How do you prove that that's group? Okay, wait. Well, no. I mean, so I'm sinking down to my chair. I'm just like deep in thought. I don't know if this is too interesting. As long as you can hear me, it should be fine. But I'm just like lying back. It gets very comfortable. But anyway, yeah. So for a given bit, the most significant bit, if the most significant bit is all ones, then you're basically done in candidates, right? So basically, well, there are multiple paths to it because it's an odd number of ones, right? Also, yeah, odd number of ones in A and just one in B, at least, and then one in C. And I guess you don't know how to partition it, but that means, but do you need to know how to partition it, or is that enough? No, I don't know that that's enough because the zeros you still have to care where they end up because they may affect swing later, right? Okay, so let's go for the case. Okay, if there's all ones, then I guess that's good, and then you go to the next one in a iterative kind of way, and you know that you maximized it, so that's good. And is that even true? Because you can have, well, you have to consider 2 bits at a time maybe because of the carry. Because you can have a thing where you have 1 0 0 somehow in the most significant bit, and then 1 1 1 would be bigger maybe in some way. I don't know if that's the right approach. Well, it is just way tricky to think about. I mean, not people got it, so maybe that's just the nature of this beast. But I mean, you understand about it. Just double checking that I'm reading it right. But okay. I think one approach that I sometimes do is that I write it out, the 3 to the n anyway, the brute force. But I don't think there's anything that I don't see. Because I mean, the brute force would be pretty trivial, so I don't think that makes sense. But what is 3 to the 19 anyway? I don't think it's fast enough. But I mean, 2 to the 19 is barely fast enough on Leetcode because Leetcode sucks. But 11 billion or something. How do I get? index, it could be either. No, but that's still 3 to the n, right? Can you? Can I dp on the number of bits? No, that's crazy talk. Because you can flip stuff back on if you do it by index. I don't think that's quite right. Which is the critical part about here? Because there's an n and there's a XOR. I guess n part is just where you dump. But maybe we can figure it out. I guess that maybe you reduce the cases. Okay. Do you get an ordering of n? Because then you could do an n cubed to the 2 to the n or something. Like, no, but then you have stuff like this. I mean, yeah, there are too many. Because then now you know, the idea is that I guess 3 and what's 6? 6 is 4 and 2. 3 is 2 and 1. So flipping this or this makes it worse. And we could just like, because if we could greedy something on the end, then we can get it right. Or we just handle n in general. Do we? Let's say we just have magically given the best n, or the n for the best result. Then you have then you know what the XOR is, and then you could kind of do it bit by bit. So you don't even need 2 to the n if you have the n, right? What is the n good for? Kind of thing, because then the rest is just XOR. You have no choice in the XOR. It's pretty greedy. That is probably true, because you can always just, you have to split up the ones, but that's basically, or just have 1 1 in one of them, and well, maybe that's still hard actually. But and 2 to the n. But still, 2 to the n is still fast enough if we're given a magical function to get n. And well, let's think about this, right? There are 2 to the 19 possible n values, and that's not even true. Is it true? Yeah, I guess there could be 2 to the 19, because you just have 18 ones in different places, and then 1 with all ones. No, that's not true, is it? Oh wait, no. No. You get, yeah, it's the reverse of what I said, but still true. Because basically the idea, I don't know if I'm wasting time like doing this, explaining it, but maybe it's worth doing it. So then if you have like all ones, and then just like, I don't know, and if you have, so I guess 2 to the 18 n values are possible. because then now you just end this one and some subset of these to flip to get every possible number. So that's 2 to the 18, right? Okay, if that's the case, okay, let's say you have, okay, you have to do it fast though. Can I do it in O of n to get, okay, so if we have these set of XOR values, can we greedy? I said maybe, but is that true? Okay, what does that mean? Okay, so that you go for the most, so then you already know the XOR. So if the XOR is 1, then only the answer is going to have 1 in 1 the bits, right? And then if the zeros and at least one exist, then you could split them up. Do they correspond? No, because the contribution shouldn't matter, right? I mean, I might try it just because I you know, I'm not doing anything else. But I don't have a good proof. Let me spend like 1 more minute and then I'll just YOLO it. Okay, so let's say you only have XOR. And I feel like that's a problem I've seen before, but I don't remember if that's true. But it's either that or some try thing. No, let's try it. I don't know. I don't know if I mean, if I'm wrong, then maybe I could figure out an answer or like a thing to it. So maybe that's fine, right? So, okay. So then, okay. I don't want to write it. Right, so the n numbers, right? So n could be 0, that's true. Okay, whatever. Yeah. No, you want this to be. Nope. Whatever, just let's just start with 1 and then no, whatever, it's fine. If well, I guess we can make it a little bit bigger, so instead if it's unchanged, then we could do it. Basically using basically it's an extra if statement, really. Nope. Okay, so then now we want to say n of nums of I, right? Right, okay. And then now we have an else, which is for the XOR numbers. Okay, yeah. I mean, I don't know that this is necessary, but let's just write it up. Right, okay. We keep track of S. Okay, and then now what? And then now we just keep track, I think. Okay, so I guess we do it this way. We don't need R, but it's fine. Maybe we can refactor it later if it matters. But I think correctness should already be good enough. Oops. If this is greater than 0, then okay. We also want to get an XOR sum. Say, don't you could construct it from it anyway, but okay. And now okay, so then now it's case analysis maybe. So if this is greater than 0, that means we have. I guess actually this is, I'm writing it. I mean it's fine, but maybe this is not even necessary. So if this is 0, then it doesn't matter which way you go, so well, just pass, I guess. So if this is odd, then can only be on one side. So then yeah, okay, I think that's fine. Oh nope, that's not fine though. Well, yeah, both sides even and greater than equal to 2, right? So then now this is actually maybe this is a little bit confusing actually. This should be an add, even though it looks a little bit funky. Because they go on both sides, and then not return, but that's not true. And then it's answer. We want to add it by the CA. Yep. Something like this maybe. I don't know if this is quite right. Well, I mean it's probably not right, but hopefully. I mean I'm not doing anything else. It's maybe the oops, almost typoed that thing. Typoed that before. 3, 5, 10. So definitely not right. Am I under? I'm under every time. Which is actually not expected, because I expect mine to be wrong. If the algorithm is wrong in the way that I expected, it would have overshot me because there's some like commingling of things. So that means it's a good sign, and that maybe I can work to debug it. Yeah, and let's see. Okay, let's say print CA or the bit mask CA R and then answer. Okay, so this, what is this saying? Bit mask is 0. That is actually that means both of these are under XOR. If both of these are under XOR, you actually have 2 and 2 plus 3. So this should be 5. This is already wrong, right? I mean, they did it in the end, but it could be XOR 2. Why? Because we have, no, but we have 1 on each side, right? So am I doing counts wrong? Oh man, this is a tough counts too. No, this is definitely wrong, because we have a 2 and a 3. Am I messing this up? Am I adding index? Yeah, I am adding the index and not the number. Okay, that's an easy fix. 5, 6, 15. I don't know that this is right, but I'm going to YOLO it because, well, it passed to the examples and I have no idea, right? This should not time out. Actually, I guess I might as well try some number. Because this is easy to do. 5, 10, 15, 17, 18, 19. Okay, something like that. I mean, this is just for one time, right? So it doesn't... We might have to optimize. If, because, for example... That would be pretty sad though, but we can convert this to Java pretty quickly because this code is pretty straightforward. I don't even know the timing of this. 8 seconds is pretty long. We can optimize this though. Let's actually make some optimization before we convert it to Java, but it shouldn't be because it's 2 to the 19. What do, right? We don't care about xsum. I don't use it at all. We can put this here instead, and then now instead of this, we can say x is equal to num sub I. And then that thing is just linear, so it was 8 point something seconds. Still slow, but I mean, well, we'll see if it's actually good first. 8.3 seconds. That's actually kind of really slow. Why is that? It's like even n squared 2 to the n isn't that slow, but 30 times n times 2 to the n. I mean, it's just slightly slower. And n times. I'm gonna YOLO submit just because Leetcode sucks and sometimes they have loose standards, but it probably time out. So let me actually just. I'm lazy today, so but this is easy to convert to a faster language. Seems like it's gonna time out. Did it time out? It's still running. Oh, that is okay. That's actually sad. And also sad that it took like so many cases. Okay, let's see. That's actually very sad. I'm gonna remove this just because it takes so long to run. There are only 4 cases. Okay. I don't know that. Oh, there's only 4 numbers, so I guess that's easy to kind of brute force it a little bit. We don't have R anymore. That's actually a little bit sad. Maybe I don't know. Okay. Okay. I mean, it is what it is. Maybe that my assumption is wrong, right? And this we can actually this may be a good time to also write a 3 to the n algorithm so that we can kind of debug it a little bit. Actually, let's do that real quick. Yeah. What's it called? Whatever, just call it ABC. Yeah, index ABC. If index is equal to n, then now we want to and we it's maybe this is. I mean, it's fine as a way to write brute force, but it's not helpful for debugging. That's why I'm. That's why maybe this is not a great way. Okay, fine. Actually, no, this is fine. I'll just restructure it another way. Because I was A, B, and C were going to be the things, but instead maybe we can set it so that score A is equal to 0 for. Score C is equal to 0. And then B, which one is B? The N, okay. Oops. Did I do it wrong? No, I did it with an N, right? Yep, okay. I mean, oh, also this is just wrong, but okay. Okay, so then we could do that, and then now we just for each one we go x plus 1. I mean, this is very awkward actually. I didn't intend it to structure it this way, but it is what it is. okay. Right. Did I not print anything? Oh, I just didn't kick it off. Okay, so what is the intended answer? I mean, I know they gave us the answer. Oh, whoops. But it's important to kind of. This is not a great answer. How do you even get that as an answer? I mean, this is B, but as a reason, I don't know if this is infinity. Huh, there seems to be some bugs. Did I do this wrong? How? Tell me. Oh, is that right? No, the extra bits should be 0. How do you even get this? What is going on? No, I did print A, B, and C. This. I mean, I have to debug my debugs. This is sad. How? I mean, that's not surprising, but huh? Is that not infinity? That's where I set it to infinity. Why are these? No. Are they different? What? Did I mess up somewhere? Is this like a magic constant that I mess up somewhere? I mean, it's true, so then why? Okay. Then why do you not set to 0? Oh, I see. I am a dumb boy. Okay, fine. I was like, I don't know if there's some crazy Pythonist that I just didn't know, because maybe that's like, you know, wouldn't make sense for it, but okay. So now everything looks okay, maybe. So here we, how do I make it a little bit wider? So 24, 25. Oh, so we did. Okay, so that actually I didn't look at this carefully. This means that our algorithm is wrong with respect to here, because I was very greedy, and it just means that two numbers can, like, I'm placing it in either way in such a way, or rather, like, there could be ones on both sides, but then later on it can only be on. Actually, that's it. I couldn't figure it out, but I mean that's kind of the gist of how I expected, right? There's no bits to be half. Yeah, okay, that seems reasonable. Can only be on one side also seems reasonable. But maybe not. Well, okay, I mean, let's look through what is wrong about this. I actually want to also just print the binary of these. I can kind of see it more visually, since it is important for this problem. Okay, so you have these things. And it's a little bit confusing. And actually, I kind of want it in, not in code, but just in a way that I can edit or whatever. So let's just print it here. Okay. I don't care about that per se, but I have to okay, actually that's not so bad. Okay, so then now I'm saying this 2489, the optimal answer is 2425. Oops, what the, I cannot paste without, I guess Leetcode is just very worried about cheaters. Okay, so variation of this, variation of this in some form. I was gonna say there's some symmetry here, but I don't know. Okay, but what I think is that the n is 902. So okay, so this is what we have. Maybe I don't have to. Oh no. Oh, so we did get that one right, but I don't know if we get that one right, but there is one of the ones that we get right. but my solution thinks there's a better answer, which maybe is wrong. Well, probably is. I mean, I mean, I guess there's no differentiation there. So 2, what does that mean? 558. So it's one of the 558s. 2 means, I guess 558 just means that it's an n, and then the rest there is some way of solving it, right? So okay, so 5. And we just kind of assumed, kind of merged them all together, I guess, in a way. We have all these bits. We have a 2 in the most significant bit. So we assume that we can take it. Okay, so which one is 558 in the middle? So which one is 558? I think it's this one. Maybe I should print it in better. But it should be in order. Okay. What is this bit? Oh, 512. Okay. So then now, let's say we took this as an n. How would I think about it? So I'm saying that, okay, this the 2 1, so we can split them up. The 2 1. Oh, I see. So basically, I mean, this bit doesn't matter, but basically you have this structure of maybe I'm doing it well. Actually, yeah. No. So something like this, so that it cannot be mutually split up. Okay, that makes sense. Actually, I was trying to think of it with 2 numbers, but 3 numbers it makes sense. So then, how would I do it? Well, the answer is, I want to say obvious, but maybe not, right? Because I only showed the existence of this, so this kind of messed up. Can I resolve this without, another 2 to the... I'll only subset on the things, but that means that it is already going to be 3 to the n, which is what we're trying to avoid anyway. All right. I see. This structure makes sense. Is that? Yeah. Okay. Yeah, actually, you see it here. Okay. So then this cannot be possible for 3 of them. Can I create a graph thing? Because basically, is it like a bipartite thing? Yeah, this is tricky with more than 3 numbers, right? That's why I'm trying to think through. I have about half an hour left. I may not get it. Wow, people got it very quickly, but Also, like, we're really slow already, so that's kind of sketch. We have to do one more thing that's not super easy. There's so many ways to split all the ones though, and then all the zeros matter now, right? Meaning that, like, is this 0 on the left or on the right when we split? That matters for this the next one. So we can greedy it. We know that they have to split, right? So, but only in this case, because if they have like 4 numbers, for example, I think this is still right. Is this still right? Yeah, because you have 1 here. It really doesn't matter where it is. And if it's an odd, because it's going to be odd on one side and even on the other. It doesn't matter. There's no other possibility. So it's only this case. And what is so it's either it can be on both sides or not, right? So how do I determine that in a very quick way? So the most significant bit, sure, right? So then how do you figure how to divide the 0 even so that it can be used later? I mean, I'm thinking of like some graph things, but I want to get time from somewhere. Can we get it from n? Like, maybe there's some better optimization on the n side instead of brute forcing on the n. I was hoping that would work, but I also had no other plans like I do now, so I mean I don't have plans now either. No, because that was just 3 to the n, which is still, yeah. No, I mean the crux of it is that I mean it may be off by a little bit, which is and we can't even do any sort of like, we don't have enough time to computationally, we don't have enough time to even just think about like, even, I mean it's so slow. If you even do another like over b complexity, it's too slow. So you can't even do b squared here. Actually maybe you can, I don't know, was it just this point maybe? Would it help if we keep track of the indexes? Can only be on one side, that's fine. Or can be on both sides, or 0 sides. So ideally you want to spread it this way actually, right? For this particular case. So that you optimize for this one and then the second number. The third one number doesn't matter as much, but again, if you have more than 3 numbers, I mean with 3 numbers it's easy to resolve. And also this isn't just a 3 number thing, right? Because you can also, I mean for now this is a 3 number thing. I don't know why there's some, you can have like actually maybe it is, I don't know, but maybe you can have something like just like a chain, right? So then how you resolve those, whatever, something like that, right? Then now you have to split up 2 different numbers, at least given the same idea. So maybe I just need a radically different idea. So it's not a 3 number thing, right? So you could say this is a graph theory thing, and there are definitely ways to resolve this, but even if you just like add a random like 1 here, then what? Well, in this case it changes, but if you have like another 1, then how do you want to split these up? That's a good question, right? Like which 3 would you have? We have 1 on each side, and if you have a 3-1 combination. Honestly, now I don't know that I have an idea. I mean, it's 19 numbers, right? So maybe the XOR is brute force. Okay. If we brute force an XOR, how do you do the N? How do you get an N? Can you get N any fast way? In this one, the optimal one is 902. But that's not the case here, right? This is... Okay, let's think about this. If you want an N, if we are able to greedy on N, what would that look like? Let's take, I mean, now that I wrote the code, I'm just trying to see whether, you know, there's anything interesting here. Maybe I don't need the A and the B, so maybe I could just write this real quick as a quick filter to look at the results. Okay. Actually, what I do, what the, I don't know. Okay. What is going on? Okay, but actually, I want to print B, the score, but also S of B. Okay, fine. I don't know what is going on in this UI, but okay. 420. Then what was it again? 2,425 or something? Where is it? Yeah, it's one of 902, right? 902 is only. Oh, happened twice. Oh, I guess it's just the refraction. But making it twice faster doesn't seem like it would probably be helpful. Is there any property that I can observe? So what happens when you add an extra number? Let's say you start with the big, you don't even use the biggest number in that, this, and even just example 3. So. I'm trying to think whether like I can think of it as an optimization problem. I don't even know if that makes sense, honestly. And we have 23 minutes left. I don't know if I'm gonna get this one at all. I don't even have an idea. This is not okay. So is there a graph? No, I mean still too slow. Okay, let's think for it backwards, right? So okay, so maybe I don't know why this is so weird. It's always weird. Okay, so basically what this is saying is that if we want to optimize for this, we want it to be on both sides, right? So basically if we have, no, but then how do you, like, what I wanted to say is that, yeah, in this case where it could be on one side, maybe we can throw away a number to the end, but that doesn't even seem like it would make sense. And we'll keep on getting smaller. Okay. If we go from left to right, now, like I said, there could be, yeah, that's the case that we had on the beginning, or maybe the end, I don't know, where it's all, you get 2 to the 18 number of unique ends, so you can't even cache on that. Okay, let's say you brute force on maybe. Okay, so x. So okay, let's say now you have a group of numbers, and you want to separate them out to an n and XOR. Because I tried. This is separating them to two XORs. What about separate an XOR and an n? Can I do that? Then now, okay, so if you have 0, that doesn't matter. If you have 1, do you put an XOR or the n? I guess if you have 1, it doesn't matter. If you have 2, you want to put it in the XOR, but that still require you to know which number goes exactly, because there probably is some commingling thing, maybe. Is it? Yeah, because if you give away a number to the n, it's the same idea of here, right? It's just that, well, it matters which number you give. Because you may use it later. Or like, if, yeah, it matters which number is on the n side and what number is an XOR side, because if there's enough ones, etc., that's not great. Okay, is there a try solution? Maybe that's what I should have started with anyway, because that was a very intuitive thing. XOR in the end, does it? Yeah, I mean, it definitely does. I just don't know how to write it in a way. Is there a meet in the middle? What would meet in the middle look like? Brute force for 1/2, and then the other half, but then you have to XOR random. Can you? Maybe you could do a try and go through all the possible cases. So then a try in this case would have 8 things each, and then 32. But not all of them are possible though, right? So is that true, Larry? I don't know. Maybe that's not true. Still can go down bad paths. I'm trying to think whether like there's like a simplex type whatchamacallit, like optimization problem that I'm trying to rephrase it into. But maybe not. Oh, probably not. I don't know. I don't know that. Meet in the middle is the. Okay, how do I think about this? So if this is a matrix, we're trying to optimize. I don't even think that makes sense. I'm trying to think. Maybe you just kind of use like one element. Would you always only use one element? Because here, then you take this one. Okay, so because you only want to put all the ones on one side. I mean, you'll need multiple. Maybe you do. I don't know. And now, okay, so let's say about this. And this is the first quote unquote separation. Does that even make sense? And then now we want to say, and then the zeros don't matter per se, but then that means that you can also put this on this side or something. I don't know if this is quite right, but this is probably close to. How do you even figure that out? Without proof forcing, obviously. I think this is close to optimal, because I know. I'm not gonna lie, I have no idea at this point. I think with 10 minutes left, yeah, when the time's over, I'm going to, actually it's a little bit late. Let me ask, I'm gonna see if I'm gonna do what I said in some of my videos, which is that I'm gonna ask my Discord if it's like some trivial, or not trivial, but trivia thing, right? Like maybe there's some facts that I don't know in general, like mathematical. I think that's the only. I don't know. Can't really figure it out. And I have a lot of energy today, so it's not even, you know. Well, mostly because I just took a late nap. I just look at my watches. Very nice weather for running, so I'm excited. But maybe I'll just. What is this handle? Is that it? I lied about it. 10 minutes. I just kind of pinged because I mean, why not? I don't know that I know anything. Something that rings a bell is some sort of like Matrix E thing. Like I don't know if there's like some like getting the dimensionality of this or something, but I don't even know if that makes sense. Is it just the way that I did it feels like a little I don't know, does it though? Okay, so let's say you have this. Okay, so you remove this. Now you have a 1 and we're good. And then now with the next bit, right? So 1 and 1. This is 0. Well, this was a 1, right? I don't think through some cases, but in this case, yeah, I mean, like we eyeball it. This is probably the way to go. Just removing this here, but right. So this thing is still true. So it has to something with the n, which. So we need something to give me like either is this or is 0. So does it matter which one we take? Like we'll just pick a random one. If we pick a random one, there are 2 cases, right? In the future. So the other cases don't matter. Like does it matter which one you take? Maybe it doesn't. Maybe here. Oh no, it does because we have to pick one where the prefix is, because we already optimized with prefix, so we have to pick one where the prefix are 0s, but that otherwise, okay, yeah, maybe we just don't do it if it doesn't. I mean, we have 5 minutes left, so we're not going to finish it in contest, but maybe I can use this reason. This feels very slow though. I mean, this is already slow enough, and I don't even do that much work here. But okay, so how would that look like? So we're basically saying, okay, it can be on both sides. So then now we find one with the prefix in which it is. Well, yeah, or the prefix in which we split. We have to care about it, right? So okay. I don't feel so great about this, honestly, but and maybe if I had more time, but I don't know. I'm gonna YOLO to try to give it a surprise, an attempt, and then yeah. Okay, so okay, so I did optimize it away, which is unfortunate, but that's fine. For X in range in R, right? So something like that. I think that's fine. Okay, but then now we have R, right? So then maybe we have to left. This is gonna be a little bit slow, but I just want to get something correct, and then maybe we'll figure out how to optimize afterwards, right? So can it be on both sides? I don't know, right? So I don't know if picking a random one works, but if it's not, then we'll do something funky. But okay, so that means that so only 19 numbers, maybe that's fine. Okay, so can we run both sides? So then now can we split them up? The answer is, and this, oh, well, this J is now, we should go from big to small, and then, and maybe like some prefix that we care about, right? Yeah. Maybe I want that to be R actually. Should not be a set. Maybe that shouldn't be a set actually. Yeah, I mean we used R, so I think that's fine actually. So can we split out? Then for yeah, we want to remove stuff quickly too, right? So that's a little bit awkward. So we want it to be like a multi-set, I suppose. Is there multi-set in Python? Why would I not know that multi-set? A bag? Just counter. Yeah, it's gonna be slow though. So okay, let's just do it this way, and we'll hack it. But can we split them up? Yeah. So then for k in range of length of R, we want to say okay. So for which one we want to consider, we want to say if J and oh, this is in yeah, maybe it should be just in R, not in range of R. Okay, with this number is greater than 0, that's good. That means the answer is yes, but and the prefix is equal to 0. So k and the prefix is equal to 0, then the answer is yes. We remove him, though quick found is equal to k. Right. We also want to update prefix to as things that we have to consider it, so that we don't move it to the wrong side. I don't think this is quite right, because you should be able to move multiple things in theory. But yeah, I don't know. Maybe maybe I'm reinventing math here. if f is not none, then we just remove it from R. So R dot remove f, I think. I don't know if this is quite right. I mean, because I don't care about the complexity for now. I think remove is fine though. Yeah. Alright, what would this look like? Does this give me the right answer? Oh, I just ran out of time actually. And this isn't even close. I mean, still got too good of an answer, which is actually worse than, I mean, this is, I don't know, we just ran out of time. Yeah, I think. Oh, I forgot to take a screenshot. Oh no. Oh, silly Larry. I could take a screenshot from the video, I guess. It's very hacky, but it's fine. Yeah, maybe not then. I was hoping that maybe I could just do like some kind of greedy thing. But this, actually it's kind of weird that this gives higher answer than necessary. Yes. Prefix, we take care about a prefix. Oh, no, this is, yeah, no, this is what I want. Why is this so weird actually? I mean, this being way under doesn't help. It should be at least strictly better than the other way that I did it. No, I guess the answer to this could be no, so maybe not strictly better. But I don't know how you get a 6 from this. No, I did already print stuff. Okay, so the reason is you have 2, 2. You have 4, the 6 is from the 2. 3 is in the end, the 2 is on the thing. How do you get 6? So K has a bit here. Am I messing something up? No, this is still on the J. Okay, well, let's see. I don't know, just printing something out because I'm really curious. How do you get a 6 then if we... So there's only 1. Am I messing some odd things up? Oh, counts is right. So why does that give 6? So yeah. Print count. Oh, answer is 6. But why? Why is this a 3? Else. Did I mess this up? Setup? No, this is right. Maybe. Alright. Oh no, it counts as just wrong, right? For 2. No, maybe that's right. No, the N is 3. So the count is definitely wrong. Why is the count wrong? I just kind of, I didn't count it, so maybe for X and R, X is 0 to num sub I. Okay, that's just dumb. Okay. Okay, well, it's still wrong actually, so that's still not great. But I just kind of copy and paste, so maybe there's some other things in it for X and R. This seems right. Well, if the counts are wrong, then yeah. The counts are wrong. If CA is 3. How do you get why are the counts so wrong? This doesn't make sense. Why are counts so wrong? This is very weird. Oh, because I okay, fine. I'm just so dumb today. Okay. I was so excited. I saw this. I was ready to submit, but the 1415 is no bueno. Why is the 1415? I mean, that's fine. Maybe I did. because we had it right, so this should be maybe if I thought a case that it doesn't think is right. Okay, so which one is the 15th scenario? The 15th scenario is the 3 and the 2, so the and it's going to be one of the 2's. So what does 1 mean? 1 means, okay, so we want the 2 and the 3, so that's a 3 on the mask. Okay, so this actually returns 11. 6 is 4 and 2, 7 is 1, 2, and 4, so this is right for the count. So then it is asking if you can split them up. Oh, because this is already split up. Okay, we could figure that out maybe. Can we split them up? Right now it is already split up. I have to do another loop. Okay, fine. Okay, so these are the numbers that are remaining. So okay, so if C is equal to 0, then we have to consider splitting them up. Oh, sorry, that's not right. If count is left is 0, then well, what do I want? If try to do math. Okay, so the odd number of ones already. Oh no, the even number of ones in total. So if this is odd, that means that half of them are already removed, or on the other side, if you will. So if this is equal to 0, then we have to consider splitting them up. Okay. Else, just add the double thing. Okay. Let's see. I think that should fix that. I don't know if this is quite right, but at least it should fix that. Ooh, and it fixes this too much still. Why? Okay, 2481. So then you have this thing that we're worried about, maybe. Is that the? I mean, this is. You don't need multiple versions of this. Okay. So okay. Oh, actually, there are multiple versions that gives you the same thing. But okay. So what was? Didn't we print this out? Okay. Yeah. So we have. Let's look at one of them. 609s. Which one is 609? 609 looks like this. Let's actually take the other one because we did look at the other one. 558. 558. Okay. We still have too big of an answer. So then you have 2, 2, 2. Okay. So we found the 902. We put it on the top, and then we put the 420, and then we put it on the top later. Oh, because when we split this, we don't need to, we have to check, we have to update the prefix. Yeah, okay, so for here we have to update the prefix so that we don't muck of it later. Is this good? Okay, okay. I mean, I don't know if it's fast enough or even clean enough or even correct enough. I guess that's the most important part. But I am still going to YOLO submit. If I could figure out how to get rid of this print statement, though this one is pretty benign because it only prints like the inputs. Yeah, how did I get this back? Okay, there you go. What? This you too? Okay, I don't know what's going on. This Leetcode interface is just. Oh man, come on! I'm not trying to play Counter-Strike here. Okay, let's run it real quick again. 5, 6, 50. Oh, it looks okay. Oh, I forgot that because the contest ended, they have this. But I don't know. Will this time out? I'm not even worried about that because I feel like we can optimize it by converting it to another language. If this is right, but which I don't know that there is. How about this? Is it still running? Oh, it's the wrong answer. Okay, I mean, I gave it my try. I'm gonna take a look. Oh, yeah. Props to Just Geo, by the way, in my Discord. And this is something that I do say I recommend, right? Which is that sometimes, like, if you don't know something and you have to prove it, then either you know it or you don't, right? And there's just no way to kind of come up with it really easy or within reasonable time. And apparently, there's this thing called XOR basis, which I don't know about, honestly. Okay, what is XOR basis? Alright. I guess for now, I mean, if we're gonna learn together, let's maybe learn together then. Okay, I'm not signed in. Okay, fine. What is XOR basis? I don't know this, and apparently it's very rare. Yeah, and it's just that Leetcode has ran out of ideas, so they're just taking random Jusako problems. So this is basically a very unnecessary thing, but okay, let's take a look. All right, XOR basis. I usually don't record me like reading this stuff, but I'm curious. Let me know in the comments if you're reading this far, whether you think this is interesting, and maybe I'll try to explain it a little bit in my own words, but maybe not in too much detail because I don't know it that well. But maybe you can kind of see how I try to learn these things. But yeah. Oh, I actually was thinking about. I mean, not the XOR part, but I was thinking of linear, some sort of things with this. And it's kind of crappy too because you just know that a lot of people kind of just Google this, right? Like it's not, or like ChatGPT or whatever, and it gives, because from my understanding is that this is pretty much tailor-made for this problem, and I just don't know it. And there are still a couple of things I don't know apparently. Okay, so. Anyway, linear. Okay, I mean, I guess I was thinking of some sort of linear optimization. Well, I don't know. I mean, I was kind of thinking along these lines, but not. I didn't have the understanding or knowledge to actually know about it, right? I mean, I kind of knew, but. Oh, not kind of new. Like I knew components of it. I don't want to sound like I'm like, oh, I knew it all along. I just mean like I guess I was thinking along those lines, but I didn't know it. Where D is the maximum possible number of bits. I mean that's fine. Yeah. Yeah, the XOR is the addition of the corresponding vectors. Okay, that makes sense. Okay. I don't. I mean, okay. I mean, I get what they're saying. I don't know how this relates to the problem yet. In terms of like right now, I'm just trying to think about like, okay, if I'm using this as a black box, what does it mean, right? Because right now we're not going over the thing yet, but linear independence can linear independence. I was actually thinking along those lines, but I don't know. Like, how does linear independence help? Okay, maybe I have to read on. Okay, I know vector space. Linear span is just okay. I mean, okay, these are just definitions, I guess. Basis. I mean, this is just linear algebra things, right? It's just the number of dimensions. Actually, did I mention that? I don't know if I did in the video. I mean, I think I did quickly, but I mean, because the thing is that the number of dimensions is and the number of dimensions you can get by ref if you have like a linear algebra thing, and if you do a linear, then maybe you can like it's kind of, I mean, I'm not doing it quite right, but well, I mean, I'm not doing it at all. But this is kind of what I was thinking of, except I just picked a random number to split up. Maybe there's a way to. What did we sort them? Oh wait. Ah, Leetcode. Why do you get rid of my submissions? I just wanted to get the wrong answer. I guess it doesn't matter, so I'll submit it again anyway. But what I want to say is maybe we could sort by R. Yeah, okay. Let's. I just wanted to get the bad input that I failed on. Because then now we're just. I don't know that. I mean, actually, it's kind of funny because this is kind of what I was trying to do, right? Because the prefix thing. Alright, now we can just run it for this one. That's what I wanted to do. And it should be much faster. Yeah, I mean, okay. I mean, still my timeout, but at least it's correct for one more thing. I don't know why I thought random would work. The reason why we do a reverse sorting, where is so that it kind of like if I have to reduce row echelon form like structure, then you would probably like. I guess I kind of wrote it. Okay. I mean, it's wrong anyway, so yeah, worth a try. But what I was gonna say is that I was thinking of like the reverse sorting is that then now you just. Because that's how I was drawing it on my matrix in a greedy way. I don't know if greedy worked, and apparently not, but that was the idea. And yeah, okay, let's keep reading. XOR kosher. The minimum number is add to such that for every two, the bitwise or okay. For every two integer a and b in a set. Oh, that's where the kosher is. Okay, XOR kosher, that makes sense. I'm trying to think what. Okay. Alright. It's too late in the day for me to kind of have to read this, but okay. Each vector is minimize it through XORing with existing. Minimizing it, I don't know what that means necessarily. Each vector is inserted into the XOR basis by it. I mean, this is how you solve a lot of these problems, but like linear algebra. I don't know the XOR part of it, but I don't know that I understand this necessarily. And maybe I need it. Oh, there are a lot of problems. Easy win is very hard, for example. I guess people just have done these problems. I mean, there's, all these, but again, kind of useless. Leetcode is not problem solving anymore, it's just trivia. I don't know that this helps me solve the one that I was thinking of. This one. Okay. I mean, I also don't know that I understand. I mean, I had some ideas around this with, but I didn't have the language to express it, per se. What is this anyway? Let's try to see the binary bits. And is if one of those things that we were talking about earlier with too lazy to do the other ones, but actually I guess I just put 0 here. And it may be just like, you know, yeah, just like a lot of commingled things. And I guess choosing even the maximum one that we haven't done the prefix yet is not great. Because of the case where you may want to put 2 in the other side instead or something like that. And it, or yeah. Or like there's 1 here. But yeah, I guess that's the case that I don't know how to handle necessarily. But then the XOR basis may get it. I mean, linear algebra is fine. I don't know, I'm clicking on more things. And how would I mean, let's say I pretend I know this. How would I even use it? I don't know, which maybe I need to understand it more. Okay, so let's, we have the N and then you have the XOR. How do we split it up? I guess, I mean, that's the problem that we're trying to solve. And the way yeah, even knowing this, I don't know that I know how to solve it. Oh, I mean, I have this idea of this matrix thing. I mean, I like how it's just like 10 lines of code and you're like, oh, okay, fine. Okay, what is this? Maybe this code will help me figure it out. Okay, you add X. Well, is there, oh no, add X is here. Basis that size, so that's the current number, reduce X. Maybe I have to ask. Oh, this is the, oops. This is for every 2 number XOR thing. Okay, maybe I can understand this form. I don't know if I would spend that much more time on this video though. Like, of me just like try to figure this out. I think in general is fine. Alright, okay, we add X. Huh, the ordering doesn't matter, huh? Okay, you add X by looking at the basis. Basis min is... Okay, I mean, this makes sense, right? Oh, this is 2 to this. Actually, maybe I misunderstood. 2 to the basis. Why? Why? Well, n is the number that exists, and 2 to the n is just the number of code. I don't know that I understand this. I mean, okay, because basically, well, every dimension gives 2 1 more power of 2, which makes sense. And then, oh, I see, because if this is not equal to 0, that means that there is at least 1 bit in which it is non-zero, and that means that those that means that this current number cannot be represented as linear XOR combination of the previous numbers. So you have to add in a new thing so that this is the new bit. Okay. So this, I mean, this I understand, I think. I don't know if I understand it to come up with it yet, but I understand. And then now, how do I get it for this? How do I extend this? So we want to say, okay, how, I mean, I feel like I have a similar but not quite idea. So that means that, okay, let's say we want to select for let's say we want to select. All right, okay. Let's say we have the dimensionality of this, all these odd numbers, right? What does that mean? Like, let's say we have 5 let's see. I mean, it's again, why Leetcode? You're terrible. Okay, so let's say we have these numbers, right? Which I have here, and then we reduce it to the number of bases, right? What does that mean? Because it's, what does the dimensionality, or yeah, what does the number of dimension mean if I have this? If a number, ooh, well, if a number cannot be represented as the previous set, okay, so you split them up, or maybe I'm thinking of the wrong way of just splitting them up. Maybe that's the issue. But okay, so let's say we have even number in that bit. What is and this, what does the basis mean? Is it just the bits that we get for free? No, I don't know. I mean, we could play around with this, I suppose, though I don't know that helps that much if I don't know how to do it. Alright, what would that look like? And we already submitted it, even though it doesn't quite save stuff. Okay, well, actually, we can go back a little bit more. We can say, okay. We can say something like this, right? So then now what? Honestly, I have no idea. So let's see. What does that look like? Yeah, okay, fine. That's fair. I just want to print out basis stuff. Let's say on the binary version, because that's no. I mean, well, yes, but it would be binary x for x, and also just how do let's see fill, and then minus the prefix maybe. Let's see if it was right, right? Okay, fine. Convert it to a list. So now they're not on the oh. Isn't there seafood, right? Maybe I mixed it up. Oh no, we want it on the left. It's just that we want it without this silly prefix. Okay, and also it's fine, but I do want to put it on the different lines. So something like this. But then now I need spaces to kind of differentiate, I think. But okay, so, and then now this is on R. All right, so maybe we okay. Yeah. Maybe that should have been a function. How can we use this? Okay, so these are the numbers and then these are the bases. What the bases? Okay. What does that mean for me? Oh no, I mean, these are really true for like 4 elements. So let's see if, well, this is a lot for the other cases. So maybe that's tricky. And then you have these things where like things are overlapping and you can even tell. But, okay. So these 4 numbers have these 4 bases. It means that, okay, that means that this is tied to this one. Okay, so this is actually, I don't know what input this is, but this is one of the, oh no. Okay, actually one thing that I do want to see is, this UI is so bad. What do I want? I wanted the case that I was saying, which is right? So that's 635, right? Let's put it in the front. And I'll just make it the basis thing, right? So yeah, oh, actually it goes really fast. Okay, so then that means that that's not the basis. Oh, I'm dumb. I forgot the if statement, didn't I? No, well, I forgot the if statement anyway, but should be if x is not equal to 0. Right? That's what they said? Yeah. Okay. But what my question is, why does this dupe add this? You add this. And then now 101, you add it again to this. Okay, no. Okay. Oh, it's, wow, what? Oh, I definitely misunderstood this one. Okay. Well, okay. I actually did not understand what was going on at all. Okay. So I may have to think about what this means again. So there's 2 as a basis. That means that these 3 numbers can be represented as 2. Or 2 of them, or yeah, okay, now I understand the linear independence part. Do I have to figure out why does this work? Why can't it just be? Wow, this is actually, I don't understand the logic of this at all, even though it's the one line. Okay, the min part. Okay, so because this part is just saying that this is the distinct component, but then I don't, how? What? I don't get the min part necessarily. Maybe my math is wrong. Let's see. Maybe I don't remember. I mean, I don't know the non-XOR equivalent, which is what I'm trying to think of. Why does this work? I mean, there are two questions right now. Why does it work, which I would like to understand, and then given this as an output, what is the result, right? And it seems like it's saying that where is it? I mean, okay, I get the linear independence part. That was the part that I was trying to figure out, right? Which is what I had this, and yeah, and the linear independence part is interesting because that means that the third one depends on these two, but I'm not quite sure how to use this to build the answer. All right. What is the answer for this one anyway? Well, let's just say n is 0. I mean, we're just trying to optimize just this part, right? In this case, we have, because yeah, we're just trying to optimize for this. Where is this? Where did it go? Oh, here's the first one, of course. That means that we want this on one side and then this on the other, right? We want the 6. We have 6, 3, and 5. Is it something like that? Yeah. The answer would be 6 plus. Okay, I have to write it out. I guess I could just write it out here. So the best answer would be just this, the divide, right? And then this, 1, 1. And then now this part reduces to 1, 0, 1 or 1, 1, 0. So then there's 12, right? The answer is 12. Do I get 12 from just looking at this? I don't think so. Basically we have these, right? Yeah. And the XOR of this is 12. Actually, what does that mean? I mean, I say that this is optimal, which maybe it is, maybe it isn't. Oh, it is, but you can also, that means that this number can also be on this one, right? And then that's also, no, this is 10. I did the math wrong. No, yeah, so it does matter. I mean, even knowing XOR basis, I don't know that it helps me to solve. So, so I think I'm about to call it, at least take a break and maybe learn offline for the explanation. TLDR, I don't know how to solve this one. I gave it even like a quick learning attempt before I take a break. But yeah, maybe I could look at this one. Maybe this is a better example. Maybe the base system. Let's see. Okay, maybe not. This is too. I mean, there's a lot of things going on. Or there are a lot of things going on that's not relating to XOR basis. I mean, I think this is fine. The LCA part you could kind of make out, but the basis stuff, I don't want to spend too much time on this. I don't know. Maybe this time we're going to do one. I mean, yeah. Even if I have the basis, I don't know that I know how to solve. Right? Because like, okay, so I mean, this case maybe, but we can construct another one, the one that we had before actually, right? Which was something like, oops. That was this one. No, wrong dimension. Okay, so this, right? What does this mean for basis? This should have either 2 or 3, but what is this? 1, 2, 4, 8, 12. Oh, 12, 16. So that's 24. They put it on the front. 24, 12, 6, 3, and then 17, right? So what does that look like? Let's put it all the way in the front, actually. Oh yeah, we know that part. Okay, so let's say this is the basis, or we have 4 independent ones, right? But what does that mean? Does that mean anything? It means that the 5th number can be represented as the other ones, but does that mean we get to split the other 2 any way we want? I don't think so. Yeah, I don't know. I think I have come to the conclusion that even if I know the basis, I don't know the answer. Like maybe there's some like reducible echelon form thing, but yeah, I don't know. Anyway, yeah. Going back to the contest, even though I don't have a screenshot of it, whatever, because Leetcode is silly. That's all I have for today. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, well, actually, let me just... Yeah, it's fine. Yeah. This is such a defeat. But yeah, yeah, don't really have much to add. Let me see if I can pull out the screenshot real quick. Oh, this is a... Okay. Luckily, I do have a lot of space because I just cleaned it up. I mean, I guess I solved... Wow, I guess I solved the other relatively quickly. Just that, yeah. I mean, I had a lot of wrong answers, but it's just that this one's frustrating a little bit more, obviously. Yeah, and this is just... Maybe this is a little bit weird. Anyway, yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.